So in this question here, we've got the position of a particle in terms of its x and y coordinates after t seconds is parametrically defined as x equals 5t to the 4 plus t squared and y equals 4t to the 4 plus 3t squared, where t is the time in seconds. And we want to determine the instantaneous speed after 3 seconds, and x and y is in meters. So how can we work out what the speed is? Well, if we've got a displacement graph, our x and y coordinates are gradient of that curve or straight line or whatever it's got, whatever it is, that is our speed. So it's the rate of change of the x and y coordinates is what we're interested in. So for the speed at t seconds, so we'll call it v, velocity t, that would be the derivative of x with respect to t. And I'm just going to leave it like that as we just build up what this equation would look like. Derivative of y with respect to t. And then what we've got, if we have our displacement graph in terms of our x and y, we may have a curve that looks something like this, for example. What we want is the gradient at that particular time in terms of t. So if t is 3 seconds appears here, we want our tangent line, and then we need the length of that tangent line in terms of its velocity vector. So that would be the Euclidean distance. So for that, we then need to find, by Pythagoras, the square root of these two terms squared. So if we've got dx dt, let's do that first. So dx dt, so derivative of x with respect to t, that's 20t to the power of 3. And this one here will be just 2t. Okay, and then dy dt, so let's do that. So dy dt, that would be 16t cubed and 3t times 2, that'd be 6t, drop the power by 1, plus 6t. So now what we want to do is define dx and dy at the time 3 seconds. So when dx at t equals 3, so all we're going to do now is plug in 3 into here. Well, 3 cubed is 27, 27 times 20 is 540, plus 2 times 3, that gives 546. Okay, so that's 546. Then here, plug in t equals 3 here for dy. So dy at t equals 3. So 3 times 3, that would give me 9, and then again 27 times 16. 27 times 16 is 432. 432 plus 18, that's 450. Okay. So that's our building blocks to plug in here. So then we've got, let's just put a little line along those. That's a proper T. So then we've got our velocity vector T is the square root of 546 squared plus 450 squared. So plug that into our calculators and we'll get 707.553, and that's in meters per second.